Hi students, in this video we're going to explore how to graph trigonometric functions and how they relate to the unit circle. Alright, so after watching this video you should be able to understand how the shape and periodicity of the sine and cosine graphs relate to the unit circle. Some big words there, we'll talk about what those mean as we go through. We also want to define the amplitude and period of a sine graph and a cosine graph, and also be able to read these graphs and work out values just using those graph reading skills that you've done in previous maths courses. Right, so some things to recall are our unit circle and how when we go around our unit circle we can get our sine, cos and tan values and how they change depending on where we are on that unit circle. Then remembering the sign of each trig ratio in each quadrant using all stations to central or whatever other memory tool you use to remember which trig ratios are positive in which quadrants. Alright, the shape of a sine and cosine graph are described as periodic. So periodic graphs repeat their shapes over and over again. Now, the reason for that is because when we think about our unit circle, here's our unit circle, what's happening is we're looking at how the values on our graph change as we go around our circle. So let's say for this first trip around our circle, we go all the way around, and then that creates some sort of graph. Right? It'll make a wave, actually, like the one we've got down here. When we get back to the start, we just do another version of our wave. And then, once we get back to the start again, another version of our wave, and we just keep going, and that wave shape just keeps repeating itself. So that repeating pattern, we call it a cycle. That repeating cycle over and over again makes a graph periodic. And we get this nice neat wave for our sine and cosine graphs. Now there's a few key aspects to our graph. The mean position is the horizontal line that goes through the middle of our graph. In this case here, our graph goes down to -1, up to +1. This line through the middle at x equals 0, that's what we call our mean position or our average position. Right? It's the average between our top and bottom of our curve. And our graph, our wave, goes 1 unit either side of that mean or that average position. Now the amplitude of the graph is basically how high and low does it get from our mean position. So in our graph here, our amplitude going up from our mean position is 1. Our graph goes 1 unit up. And then in our trough, our graph goes 1 unit down. So in this situation, our amplitude is 1. Now the period of a graph, the last one here, the period of a graph is the time taken to complete one full cycle. So looking at our graph here, we might start up here at 0 at a peak, and then we get back to that peak up here. Now, a bit hard to read, but you might be able to guess. We get back to our peak at 360 degrees. And again, going back to our unit circle, well, if we start here at 0, we go around, we get back to the same point after 360 degrees. So that's why for our graphs y equals sine theta and x equals cos theta, they have an amplitude of 1 because our unit circle has a radius of 1, and that's got a period of 360 because when we go around 360 degrees in our circle, we get back to the same point. Alright, so graphing these and where these graphs come from. We'll start off with our sine curve. So if we want to plot here y equals sine of our angle. Now this graph here, this sine value, we'll use the sine values from our curve. And remember, the sine values are the y coordinates on our unit circle. So looking at this point here, our y coordinate, right, when our angle is 0 degrees, our y value is 0. So it makes sense to start our graph when our angle is 0, our y value is 0. Now when our angle gets to 90 degrees at the very top here, Okay, our y value is now 1. So at 90 degrees, which might be about here, our y value ends up being 1. Going all the way around here to 180 degrees, our y value is 0. So 180, just a bit below that, so maybe here. Our y value goes back to being 0. Finally, down here at negative 270, or 270 degrees, our y value is negative 1. So 270, that line there is 250, so a little bit more. That will be negative 1 right here. Also, before finally, when we go back up, when we get to 360, our y value is once again 0. So that'll be about here. And then the pattern should repeat over and over again. So our sketch, yeah, a bit off. So 360 is about there. That makes sense. This line here should be about 350. And so there's our sine curve, just drawing that wave function between those y values as we work our way around. All right, this time we're going to draw our cos curve. So y equals cos of our angle. And so looking at our unit circle, our x values are actually the value for cos. So what we're going to do is plot a few of our points, and then from there work out some points that we can use to draw our graph, just like we did for our sine curve. So here at 0 degrees, right, our coordinates are 1, 0. So our x value at 0 degrees is 1. So for 0 degrees, our x value is 1. That's a good place to start. Going up to 90 degrees at the very top here, the coordinates of that point are 0, 1. So our x value is 0. So at 90 degrees, maybe about here, our x value ends up being 0. Our cos value at 90 is 0. Working our way around at 180, the coordinates of that point are negative 1, 0. So the x value, the cos of 180 degrees, is negative 1. So that'll be just a little, so that's 150. So maybe a little bit about here. Also. And then going down to 270 degrees at the very bottom here, our coordinates are 0, negative 1. So our x value, our cos value, once again is 0. So we've got 250 here, right there. So we're looking about here. Also, for 270, and then going back up to 360, we get to the same point and can use 1 again. So there's 350, a little bit more, gets us to 360. And then our wave will continue. So drawing between those dots, there's our nice neat cos wave. Now notice the only difference between our sine and cos wave is where they start. Our sine wave started in the middle at 0, at our mean position. Our cos value started at a peak. So they're exactly the same shape, just the only thing that's different is how they start and where they start. Sine curves start in the middle with our mean position. Cos curves start at the peak or sometimes at trough. All right, so we're going to use some graphs here to determine some values. We've got y equals sine theta, and we want to find out when the y value, when our angle is 140. It's pretty straightforward. We'll just go to 140 on our graph, which is about here, and we'll read off a value. And that's approximately 0.7 for our y value. So we're just reading off a graph there. In our second one, we're going to do the same thing. When y equals negative 0.6, so there's y negative 0.6. We'll draw a line, and from the 2 points, we'll measure those angles, and we're looking at about, our theta angles look like they're about a bit more than 110, so let's say 210, so we'll call that 212, and this next one is a little bit less than 320. Let's just call it 318 degrees for that value there. And again, we're just reading off a graph to find those values. Right, after watching this video, you should be able to understand the shape and the periodicity, so how that shape repeats for a sine and cosine graph, and how we use the unit circle to sketch those. Work out the amplitude and period of a sine and cosine graph, and also read those trigonometric graphs too.